In some reorder point problems, you have to determine a reorder point. In other reorder point problems, you have to evaluate a reorder point. This particular problem is an example of the latter, of having to evaluate a reorder point. Let's take a look at it. The Office of Environmental Studies uses reorder point system to govern ordering of new shipments of public information flyers. Okay. Demand for public information flyers varies depending on the number of public visitors to the Office of Environmental Studies receives each day, and the delay between when the office requests a new shipment of flyers and when it actually receives a shipment can also vary. Oh, so actually, what this is saying at the beginning, so I'm going to take some notes, is what sort of situation are we in here? We are in a variable demand and a variable lead time case. That's just what's been described here, right? The number of visitors each day can vary, and the delay between when they request a shipment and they actually receive it, that is the lead time by definition. Now, why did I jot down? Because that might prove important later if I have to derive the distribution of demand during lead time. I need to know what situation I'm in. Okay, both these things can vary. All right, now that was just a note to myself. Let's continue reading on in the problem. Thus, based on past experience, the Office of Environmental Studies estimates the demand for flyers, oh, wait a minute. Demand for flyers during lead time on a new shipment is normally distributed with an average of 200 flyers and a variance of 50 flyers. Oh, wait. I'm probably not going to need that information because if I understand them correctly, they just handed me the overall distribution of demand during lead time. Reorder points are all about demand during lead time, and what they just said is overall during lead time they need an average of 200 flyers and there's a variance of 50. So this is the natural variation in demand during lead time for these public information flyers. It looks essentially exactly like this. All right, now what else are we told? If the Office of Environmental Studies reorders when its stock of flyers falls to 215, important to recognize, if it reorders when the stock of flyers falls to 215, that is the reorder point. They are asking you about a reorder point of 215. They're just not saying reorder point. Oh, all right, so that would be drawing a line on that natural distribution of demand during lead time and saying, fine, we reorder here at 215. All right, that's one illustration of that. What else? What is the chance that the new shipment will arrive before the office runs out completely and must disappoint a visiting member of the public? We have another name for that. Okay, chance the new shipment will arrive before the office runs out completely and must disappoint a new visitor. We call that the service level. So, service level. So one challenge with this particular problem is to simply discern what is it that you need to find, because this particular problem is talking about all the basic elements of a reorder point, but it's not saying anything by name. Okay, the chance that the new shipment gets there in time, right? You don't have to disappoint anybody. That is the service level of our reorder point, right? The probability that the demand will not exceed supply during lead time. All right, they didn't even ask for a reorder point by name, but we recognized it for what it was. Reorders when the stock falls to 215, that's exactly what it is. All right, well, they just want to know that, okay, if they reorder at 215, right, what actually is that? Oh, so we need to remember, and this is where the illustration of the normal distribution is helpful. We need to remember that the area of the curve that's to the left of the reorder point, that whole combined area, the proportion of the curve that's trapped to the left, that represents all the various lead times in which demand did not exceed supply during lead time. More people didn't come in than we had reordered at. That combined area, that portion of the curve that's to the left, that tells you the service level. We just need to figure out, okay, fine, if you had a normal distribution like this one right here, whose center is at 200, its mean is 200, and its variance is 50, and you drew this line at 215, fine, how much area is here to the left of it? So I really wish I had this table. A table that for a normal distribution with a mean of 200 and a variance of 50, right, it would tell me the area given, you know, like I cut the curve at a certain place. Well, I don't have any such table. Not for a curve with a mean of 50 and a mean of 200 and a variance of 50. But I do have this table. The standard normal table. The standard normal table tells me the area of the curve that's to the left, see the illustration, if I cut the curve at a certain point, given that the curve has a mean of 0 and a variance of 1, that's what the standard normal curve is. It's just a particular normal curve that happens to have a mean, an average value of 0, and a variance of 1. You say, well, that doesn't help us because our curve has a mean of 200 and a variance of 50. Ah, yes, but wait a minute. Why is this table in the back of virtually any business analysis textbook that there ever was? Because you can very easily translate your curve into a standard normal curve. You just calculate the z-value. Right, z, right, what does it say z here? Z equals the number that I'm interested in minus the center of my curve divided by the standard deviation of my curve. Oh, all right, so in our particular case, the number that we're interested in is 215. That's where we're cutting the curve on a curve that's center is 200. And here's where I need to be careful. Yes, you do put 50 in the denominator, but remember to take the square root when calculating the z-score. Right, it's known as a z-score. Right, because it's always the standard deviation that's in the denominator of the z-score. In this particular problem, what they reported to us was the variance, right, or the standard deviation squared. Okay, so we take the 50 and we take the square root of that. Okay, so this turns out to be what? 15 divided by the square root of 50? I get 2.12 some odd. I'm rounding to 3 digits. I get a z-score of 2.12 when I say 15 divided by the square root of 50 on my calculator. Okay, fine. What's this have to do with the Office of Environmental Studies or whatever it was? This is the number that we need to look up on the table. It will tell us the service level associated with a reorder point of 215. Oh, how do you use the z-table? You look up the first 2 digits, 2.1, as the row. Okay, that's right here. And then you look up the 3rd digit as the column. I would add 0.02. Okay, so at the intersection of those 2 things, that's my area. Right there. A z-value of 2.12. The table is reporting 0.983. 0.983. Can't remember that number, but what's it mean, 0.983? It means 0.983 proportion of the curve is actually to the left of the number that you're interested in. Oh, perfect. That's the service level. Service level equals 0.983, or, you know, more conversationally, 98.3%. If the Office of Environmental Studies reorders at 215 flyers left in stock, there is a 98.3% chance that in fact they're going to have enough flyers while they wait for the new shipment to get there. There is a small chance, you could subtract that from 1, that they might run out. That would be the stock out risk. But the actual answer to the question, which we got from the z-table by calculating the z-score, is the 98.3%.